Imagine standing in a river and watching ice grow on the surface while the water keeps flowing underneath. Sounds impossible, right? That's because the river you're looking at is doing exactly that, and it's a mind-blowing example of physics in action. First, let's break it down. When a liquid starts to freeze, it normally loses heat from its surface. The molecules at the top become slow, stick together, and form a solid shell. As the shell thickens, it should stop the whole body from cooling, yet in a river, the water still continues to move and chill. How does that happen? The trick is called supercooling. Water can drop below its normal freezing point 0 degrees Celsius without turning into ice if it's incredibly pure and undisturbed. In a river, the water is stirred by currents, so when a chunk of cold water is tucked inside the warm mass, it clings to the cold surface and starts to freeze. The ice that forms at the surface is like a tight, invisible blanket. Here's the kicker. Once the surface ice reaches a critical thickness, it isolates the underlying water from the air. That means the ice stops all further heat loss from the water below, so the cooler portion can stay supercooled. The result is a floating ice layer that keeps growing upward, while the water underneath keeps flowing and stirring. Some scientists call this a frost front, an invisible line moving upward through the water. As the front advances, it pulls more cold water from deeper in the river, keeping the surface ice from forming a solid barrier that would stop the flow. The river effectively pumps cooling from the bottom to the top. You might wonder, why not just cool the whole river evenly? The answer lies in efficiency. The river's flow structure creates a concentration gradient of temperature. The cooler, denser water stays near the bottom, while the warmer, lighter water stays on top. The supercooled water on the surface then circulates upward faster than it would if the whole river were uniformly cooled. This phenomenon isn't just a curious quirk, it's vital for ecosystems. The water stays liquid long enough to support fish, insects, and plants, but the ice from the top creates a habitat for organisms that thrive in cold, thin ice. And while the surface looks calm, the river below remains a bustling, swirling network. So next time you see a river in winter, remember, the ice you see on the surface isn't just a passive blanket, it's a dynamic front pushing against the flow, using physics to freeze from the top down. It's a beautiful, mind-blowing reminder that even the simplest scenes can hide some of the most fascinating science. If you found this riverside mystery as cool as I do, hit subscribe and drop a comment on what nature's tiny secrets you're curious about next. Stay amazed and keep exploring.